in order for us to start using R, we have to import or create data. In this episode, we'll learn how to create objects in our environment. Not only vectors, but matrices. By the end of this episode, you'll know how to look at tables that we in data science call data frames. But before we jump into data frames, which are more advanced, we can start with the basics. The most basic element in R is called a vector. Everything is based on vectors, whether it's a matrix or a more advanced data frame. A vector is a building block in R. You are probably asking yourself, what is a vector? And that's a great question, right? What is a vector? A vector is an object in a vector space, and that's not really helpful, right? But what is helpful is to visually understand how a vector looks like.
One of the most common vector spaces is the Euclidean space, and we'll visualize vectors in 2 dimensions, called the plane, and 3 dimensions, called space. What we are creating here is a plane, with a point that has coordinates a and b. If we connect the 0, 0 point, called the origin, and our a, b point, we'll get a vector. The tail of the vector is in the 0, 0 point, and the head is in the 2, 3 point. We can say that we can describe the vector using its direction and magnitude length. All of this becomes more interesting when we try to visualize a vector in 3 dimensions, called the space. And just try to imagine the same principles in 4, 5, or 6 dimensions.
By now, you might think that vectors are extremely complicated, but that's not true. But what you actually need to remember is that a vector is an object with elements, and the order matters. The order of those elements matter. So how does a vector in our R world look like? Well, it has elements, and I'm going to represent those elements by using these sheets of paper. And let's say that we're going to create one vector with 6 elements. Element number 1, element number 2, element number 3, element number 4, element number 5, and element number 6. So I have a vector with 6 elements. 1, 2, 3, 4, 5, and 6. Each element can store different data types, different elements, let's say numbers from 100 to 106, or names of my roommates, right? It doesn't really matter what these elements store, but what matters is that they have order. They have what we call an index. Index number 1, index number 2, index number 3, 4, 5, and 6. By now we know how a vector looks like in the Euclidean space, 3 dimensions, and also in the plane, 2 dimensions, connecting 2 points. We also know that a vector can be simply put numbers with an order, with an index. Index number 1, index number 2, index number 3, 4, 5, and 6. But how does a vector look like in our RStudio? Let's go to RStudio. Let's open up a new script. I'm going to go to the white plus sign on the green space and open up a new script. In this new script, what I'll do to create a vector is I'll use the C function, lowercase c and parentheses. In these parentheses, I will type 6 numbers, 101, 102, separating each number, each element of this vector with a comma, 103, 104, 105, 106. A vector with 6 elements. Now if I want to submit this code to R, I can either highlight this code and click the Run button, or I can simply click with my mouse on this line and do Command Enter or Control Enter if you are on a Windows computer. So this is my code. This is the code, exactly what I've submitted over here from my script. And below, R responded with the same data. It printed my data. What I can also do with this vector is save it as an object in my environment. What I'll have to do is I'll have to create a name for this vector. Let's call it my underscore vector. To assign this object to this name, I will have to use the reverse arrow, not an equal sign, reverse arrow, and copy my object on the right-hand side of this vector. So on the left-hand side of this reverse arrow, we have the object's name, and on the right-hand side of this arrow, we have the object. We created the object. So now, if I highlight this and click Run, the console printed my code right here, and it saved an object in the environment, third window. It's in the values section. It was grouped as a value. It's called my underscore vector. It's a numeric object with 6 elements, 1 through 6 elements. 101, 102, 103, 104, 105, 106. Let's create one more vector using a different function, because maybe we'll notice that we want to create a vector with a pattern. So now let's just create one more object, my underscore vector 2. Reverse arrow. I'm going to use the rep function. Okay. In this function, I will use a small vector with 2 elements, 101 and 102. And I'm going to use each of those elements 3 times. Right? So a very small vector replicated 3 times. Bingo! And I got a new object in my environment called myVector1 that is a numeric vector with 6 elements. 3 times 101 and 3 times 102.
What we have here is a row vector. It's in a row. But you can also have a column vector, which looks very similar, but is in the opposite direction. It starts from top and goes to the bottom. Just because we don't have enough space, I'll create a small vector with only 3 elements. Element number 1, 2, and 3. Index 1, index 2, and the red is index 3. We know what vectors are. Let's go back to our one-row vector. We know that these are consecutive elements. Let's assume from 100 to 106. But the next question would be, is there anything more advanced? As you can imagine, your options and possibilities are limited with just one vector. What if I were to introduce a second vector, a second row vector with 6 elements as well? Element 1, element 2, element 3, 4, 5, and 6. Let's assume that these elements have numbers from 200 to 206. What I can do with these 2 vectors, since they have the same dimension, 6 elements each, I can stack them together and create a matrix. Which means a matrix will combine both vectors into one object. What is more, before we had one index, 1, 2, 3, 4, 5, 6. We could describe each number in our vector, or each element in our vector, using one index. Now, we have 2 dimensions in a matrix. So to describe our elements, we have to use not 1, but 2 indices. This index that we've used before, and a row index. It's going to indicate which row our element comes from. So let's say that we want to grab the element from the second column and first row. That's this one. Now what if we want to take the third column, second row? 1, 2, 3, third column, second row. It's this element. So again, our matrix
has 2 dimensions.
Let's take a look at one more example. We'll draw another matrix, but let's start with a simple vector that has 6 elements. Our next step is to write down the index of each element, index 1, index 2, index 3, index 4, 5, and 6. Now we'll add data to our vector. After that, we'll add 2 more row vectors that are empty, and it's up to us to add data to the 2 new row vectors. We'll end up with a matrix that has 3 rows and 6 columns. Now that we know how to create vectors in multiple ways, let's try to create a matrix from one of these vectors. We'll use my_vector with those 6 elements to create a 2 by 3 matrix. 2 rows and 3 columns, 6 elements totals. What I'm going to do is I'm going to create a new object called my_matrix and use the matrix function to create it. And if we just simply stop before putting in the parentheses, we'll get a helper box that says matrix, our function, and gives us all the required arguments of this function. We have to specify what data to use, how many rows we want, 2, and how many columns we want, 3. So let's create this matrix function. Data equals to my_vector, and row equals 2, and col equals 3. 2 by 3 matrix. And if I run this, I will get a new object in my environment called my_matrix. And it was classified as a data object. Numeric, of course. And now, 2 dimensions. 2 dimensions versus only 1-dimensional vector. 2 dimensions, 2 rows and 3 columns. And if I double click on my matrix, it'll pop up in this window. 2 rows and 3 columns, 6 elements.
We've built a beautiful matrix, a more advanced object than a vector. It can store more data. It added a 2nd dimension. We had the column index and we had the row index. Now let's take those 2 dimensions and ask ourselves a question if there is even something more advanced that will give us more information regarding this data. The object is called a data frame. A data frame will look just like a matrix, but it will have column names and indices, and it could also have row names and indices. But what is more? Just like with the matrix, we were limited to the same data type. A data frame allows us to store different data types. So this column here, this variable here, let's say the 2nd column, can be a character, versus the 3rd one could be numeric in a data frame. A data frame is more flexible.
Okay, if I double click on the matrix in my environment, I will pop up the data points. And I'll see 2 rows and 3 columns. However, this doesn't look quite beautiful just yet. There is a better object that we can use to store this data. The most ultimate object would be a data frame. That's where I can modify the column names or maybe add different data types like characters, like dates. So let's try that. I'm going to create a new object called my_data_frame, reverse arrow, and use the as.data.frame function. And I'll use my_matrix as the data input for my data frame. And if I click Command Return or Control Enter, I'll get a data frame in my environment. This new data frame has 2 observations and 3 variables. That is very similar to 2 rows and 3 columns because it is the same. In a data frame, we don't say rows, we don't say columns, we say observations for rows and variables for columns. different verbiage. And what I can also do is click on this blue circle here with the arrow and get a list of all my variables in this data frame with the variable types, in this case all numeric. I'll also get the first few observations for each of these variables. But I can also double click on this data frame and it'll pop up here with my 2 observations and 3 variables.
You might have noticed that we started talking about different data types. So come back for the next episode and we'll learn more about different data types. Thanks guys, bye.